Hey everyone, I just wanted to take a brief moment of your time to just do a quick refresher on similar triangles. Examples would be like the one that I presented to you on the screen here. So I have a smaller right triangle that has a 30, 60, 90 degree measure for its interior angles, and then I also have a larger one in red with the same ones. So one of the first things that you do want to note here is that similar triangles will have the same interior angle measurements. Okay, so if, for example, this smaller triangle had a 30, 60, 90 degree interior angle measurement, but if you went to the other one and it had maybe like a 90, 20, 70, they would not be similar triangles anymore. So one of the first things that we have to note here is that for a similar triangle, they need to have the same angle measures. The next thing that we can talk about now is going to be the side measurements. So say, for example, my smaller triangle here has a side measurement of, let's see here, let's do 3, 4, and 5. Okay, so if I go over to my larger triangle, I might have a measurement of 8, 6, and 10. So what we should be seeing is when we look at similar sides that we're going to get the same proportion or the same ratio. If we, say for example, did a ratio that had the small side measure over the large side measure. So really quick, we'll go ahead and we'll prove this. So if we take a look at, say, the hypotenuse, if I did a 5/10, this reduces to 1/2. If I were to go ahead and take a look at the leg that's forming the base of our right triangle, this would give me 4/8, which also simplifies down to 1/2. And then lastly, if we were to take a look at the third side, we would have a 3/6, which also boils down to 1/2. So we do want to say that similar sides create the same proportion. Okay. This topic will actually help us as we start looking at the idea of, or the functions for sine and cosine. So I hope that this little intro video was helpful. If you do have any feedback for me, please let me know.